Okay, so this is EME at N0TB's location. And Tim, I'd like to introduce Tim Blank from Byron, Minnesota, in Rochester. One of the things about Tim that I didn't know was he's also a private pilot, and he also does aviation photography. I presume that means taking pictures of airplanes or taking pictures from airplanes, or both. I see he's also DXCC #1 on the honor roll, and he's got like a whole bunch of these awards. I won't go through them all, but the thing that caught my attention was his 4x8 monster project there, putting this big antenna array up. This is kind of been one of my dreams, which I don't think I'll ever do, but it's nice to see somebody else who can actually do something like that. So without any further ado, I'd like to have Tim take over and give us his presentation. So Tim, it's all yours.
All right, thanks, Paul. Let's see if we can get this sharing part to work right here. Let's see, share screen. And let's get, there we are. Let's do share slideshow. There we go. How do we do the slideshow part from the beginning? Can you see that okay?
Perfect.
Oh, yeah. Perfect.
All right. Well, I am privileged to be able to join your call today to talk about this a little bit. I'm kind of a newbie on EME, and there are a lot of people that have a lot more experience and time than I do. But you know, I'm glad to at least share some of the things that I've learned and what I've done over the last couple of years. This picture, actually, I took this picture also. I do astrophotography, and so this picture actually came off a telescope in my backyard. It's kind of a mosaic of like 5 or 6 pictures. Moon is actually pretty big looking through the telescope, and you gotta have to take 6 pictures and then mosaic them together. So anyway, I call it like the ultimate journey to ultimate DXing, mostly because that's a phrase that was introduced to me by N0TB years ago. He used to tell me when we used to work in the same facility, and we'd meet in the hall, and I'd talk to him about my DX accomplishments, and he would just kind of scoff at me and say, "It's like, well, you think you're working DX?" It's like, I've already worked 550,000 mile DX, so I don't think that yours really counts. But so that kind of put the bug in me. But anyway, so what I'm going to talk about tonight is a little bit about who am I. Kind of go through some of the thought process and maybe a little bit of the math on how I selected the particular antennas and the tower that I did. Go through some of the milestones associated with doing this. This whole project has taken several years since it was conceived. So it's not a project that you can just kind of start today and be done with it in a month or two by going out and ordering parts on the internet. Like a kit or something. So it's kind of a lot of custom stuff that has to be kind of done to put it together. One of the main cornerstones of any like EME type of system is the elevation rotor, and there are a few of them that are out there. This one is done by K7NV. It consists of a couple of prop pitch motors and some special hardware, and I'll have some details about that and some pictures that we can see how it's put together, and talk about that a little bit more. I'll talk a little bit about the cross-country adventure that several of us went on here to go pick up the parts in Nevada from K7NV. That was fun. The antennas came from Justin G0KSC. We'll talk a little bit about those and some of the modifications that I made to those. Talk a little bit about my station and the hardware and software that I use for making EME contacts. We'll talk a little bit also about the pattern of the array from an EasyNet analysis that G0KSC Justin did. And we'll close it up with a little bit of recognition. This is such a huge project, and really I'm just one guy out in the country here, and I really wouldn't have been able to do it without a lot of help. And so I'll just kind of briefly show you the list of kind of the people that have been so key in helping me get everything, getting it done. And some of this work is kind of physically hard, and for one guy like myself to do it would have been taking me a lot longer. So help was key. So who am I? I was originally WN9GYU, first licensed in '71 back in southern Wisconsin in the city of Janesville. I was introduced to ham radio by actually an 8th grade math teacher. Used to have the call of W9KRP, now he's W9BJ. He had a Hallicrafters receiver set up in the corner of our math room, and hearing this activity, from all around the world, and being able to listen to people in Russia, and it just kind of intrigued me. So it wasn't long that I was able to get my novice, and that was in April of '71. By the time I was 15, I had gotten DXCC, and that was in July of '72, primarily on 15 meters. Back in the day, of course, for novices in the United States, we are limited to 75 watts and crystal controlled radios. So, using that hardware as a home built transmitter and dipoles, I'd already gotten 34 countries and worked all states. So I was off to a good start to get the XCC by the time I was 15 in 1972. Of course, as is common with people as they move through their stages of life, I graduated from high school in Janesville and started my college education in the University of Wisconsin. In January or December of '80, I had graduated from University of Wisconsin-Madison with an electrical engineering degree and moved to Minnesota. Started working for IBM, and that's actually right away I met Terry, W0VB. He was one of the first people I met when I came to Rochester. I have a lot of fond memories of talking to him and giving some presentations to the local IBM club on a power supply that I had built. And after a few years of living in an apartment, I built a house in rural Byron on 2 acres and bought some equipment, got active on 160 through 10. And by 2005, I achieved #1 honor roll. Oddly enough, most of my history up to this point had been primarily HF. Like I mentioned, I started on working 15 meters and kind of branched out to 20 and 10 and working my way out. But when I built the house, I put up a 40 meter Yagi and 80 meter inverted Vs and started to work the low bands. And one of the things that I wanted to achieve was kind of DXCC challenge. to get to the 3,000 level, and I very quickly realized that I wasn't going to be able to do that without having some 6-meter capability. So I put up a M squared M6, the 6M5 XHP, which is a 5-element M squared antenna on the top of my tower, which puts it about 90 feet off the ground, and started using an ICOM 706 Mark II that I won at a ham fest, and started working DX on 6 meters in 2014. So that was really my first experience on 6 meters. So I haven't really been on 6 meters all that long either, especially when you compare it to guys like Terry, and I'm sure that many of you guys have been on 6 meters far longer than I have. They always tell me stories about F2 and working DX that way, but I've never had that experience. Everything I've ever worked has always been sporadic E and now on EME. I added an ACOM 1500 amplifier in December 2014 to give me the 1.5 kW on 6 meters. As Terry mentioned, I mean, we lived about an hour or a mile apart from each other, and when I first talked to him about getting on 6 meters, he always used to tell me, he was like, oh no, you don't need any power on 6 meters. You can do it with 100 watts. But it didn't take me long to figure out that really what he was trying to say was, I don't want to have a guy with 1,500 watts a mile away from me. And I really kind of wised up to that and decided I really needed power on 6 meters in order to be able to work the DX that I needed to. A couple years after that, let me back up a little bit. And again, this circles back to Terry. Him and I have a lot of really interesting stories. We used to talk in the hall a lot about the DX that I was working on 6, and he was a newcomer to the Flex community and had about a 6700. And one day he came up to me and said he could kick my butt at any pile up on the low bands with his new Flex radio. My reaction was to kind of look at him and throw up my arms and turn around and just kind of walk away and mutter a few expletives and say, I can't believe he has the audacity to say that to me. I was using a Kenwood 930, so I was kind of old school. But after I kind of started on 6 meters and realized that there was this wide expanse of band that I needed to be able to look at, and after seeing his equipment going over and seeing the Flex in action, I kind of bit the bullet and bought a 6500 of my own in January of 2016, and started to work digital modes. So up until 2016, I really have never even worked RIDI or anything digital. So I haven't been on that mode for that long either. And then in 2020 here in January, I added the PGXL, mostly because I was tired of waiting for 3 minutes for the amplifier to warm up. Well, the pileup was going on on 6 meters, and that's kind of the longest 3 minutes of your life, especially when the openings on 6 meters are as short as they are. So in February of 2020 was when I achieved to get to the 3,000 level of the XAC challenge, which is a huge lifetime goal for me. And mostly that was to do, I can say, with getting 98. By that time, I had 98 countries on 6 with terrestrial, sporadic E, QSOs. So, and why did I decide to do this EME stuff? And the answer kind of is that after 98 countries, and it starts to get kind of hard here. And I'm sure I'll get to 100 countries terrestrially, but it gets harder and harder as you get up to this level of countries on 6 meters. And besides, the openings are really few and far between. The sporadic E season only lasts for a couple of months. And, being from the Midwest, I mean, it's a challenge. And besides, I kind of like to build things. It's kind of a passion of mine. It kind of harkens back to my engineering background. And so building this antenna was kind of something that I viewed as kind of one of those bucket list things. And like as I had mentioned earlier, Terry was the one that kind of got me first thinking about getting on EME, and Terry has always been big into VHF, and I think he even was like #1 220 megahertz worked all states EME. And so I mean, he was a significant record holder in that space, and so having him talk about this and was always kind of something that kind of intrigued me. Also, Dave Schmoker, KJ9I, another longtime friend, is also on 6. Has also been on 6 for a long time, and has been on 6 meter EME also for quite a while. And he would quite often talk to me about how much fun he was having with that, and the contacts that he was making. And so I think the combination of Terry and Dave kind of planted that seed in the back of my mind that maybe this is something that I should look into. And about 3 years ago, Dave started discussions with Kurt K7NV about how to, what he would like to see in a 6 meter elevation or an elevation rotor system capable of a large 6 meter EME array. And this is before I was involved in that. So, I mean, they've kind of got that ball rolling, back around 2017. And then 2018, after a number of discussions with Dave, I decided to join in the development of that elevation rotor with the intention of Kurt actually building 2 of them, one for Dave and one for me. And kind of one of the first things that that I also had to kind of talk about or with Dave and think about is what kind of antenna I really wanted to put on in this array. And thanks to Lionel's superior reference material, I could study this and talk to Dave about what the options are. And I think discussions kind of ran anywhere from a 4x5 to a 4x10 array. Eventually, I settled in on 8 element, mostly because of the law of diminishing returns. Is kind of, as you start to add the number of elements and get more and more gain, for a 3 dB gain, you basically have to almost double the boom length. And so quite rapidly, you start into getting, really, really big antennas as you go from 5 to 10 elements. And also that directly translates into more wind load, and which again also translates into having to put up a taller tower, because if you're going to elevate these things to 90 degrees, you have to be able to clear the ground, and so that forces you to raise the whole thing up in the air, which makes, of course, the whole discussion to be a little bit more costly and problematic, because you have to keep getting bigger and bigger towers to get that extra 10 or 15 feet. So one of the major factors that I used in my thought process and my thinking was to kind of use this G/T metric to kind of pick the the antenna, the 12.49 meter boom 8-element LFA, which seems to kind of rate pretty well with its competitors in terms of that particular metric. And it has it's a 12.49 meter boom, roughly 40 feet, and that's about as big as I think I can probably turn on the property that I have without knocking down even more trees than I had to. It does take a little bit of space to put something like that on a piece of property. So given that I had settled on the 8-element that LFA, I started to look at what kind of tower would support it, and started kind of going through some of these numbers, scratching them out and figuring out which tower would do the job for me, and kind of roughly speaking, the wind load that I kind of calculated out for 8-element LFAs was somewhere between 21.4 square feet and 34.4 square feet, depending upon if it was aimed into the wind or aimed perpendicular to the wind. And looking at the Roan tower specs for under the 90 mile an hour rating, you can see that Roan 55 only has an 18.5 square foot wind load capacity at 25 feet. If you go to Roan 65, it has a 52 square foot wind load capacity at 25 feet under the 90 mile an hour wind specifications. So given we have, at worst case, 35 square feet of wind load, Roan 55 is not going to handle it. I'm at least going to have to go to Roan 65, and so that's what I settled on. Now, obviously, ice load is going to affect this wind load number that we're talking about here. And that's a concern. But given that this is a 90 mile an hour spec on the tower, we typically don't get 90 mile an hour winds in the winter. You might see 50 with an ice weather system, but not 90. So the 52 square feet number is pretty conservative. You might see 90 mile an hour in the summer in a thunderstorm, but there's no ice involved in it. So starting in May of 2019, we started cutting down trees, and we had to cut down about 5 of them. This particular picture is my son-in-law, who had never actually used a chainsaw before. And so I didn't know that before I handed him the chainsaw, but I got him and my daughter and neighbors to help out with cutting up the wood and hauling it out and renting a stump grinder and getting all that stuff out, cleared up so that I can put a tower up on the top of my hill in the back of my yard. Then after ordering these towers, after like a couple of months, the FedEx truck showed up with 3 sections of Roan 55 and 3 sections of Roan 65. And if you look carefully at the back of the truck, you can see that they bent the crap out of the rungs. It was kind of weird. The guy was like, oh yeah, I put this forklift in here and I had a heck of a time moving these around, and I kind of had to, like come around this side and put the forks under there. And sorry about the bend, the bends, but it's like, geez, thanks guys. But I was able to get those straightened out, and I think the worst one I ended up putting that in the bottom of the hole, so we can't see it anyway. But anyway, that kind of gets us to about August of last year, 2019, when these first showed up. So shortly after that, he had a guy with a backhoe come in and dig me a nice 6-foot hole. Recruited my son to jump down in there and square it off and dig the loose stuff out of it and put some gravel, put 6 inches of gravel on the bottom of it, and then built a frame and had the thing all plumbed up, and then called in the ready mix, Rochester ready mix cement truck to come up with 8 yards of concrete and get that all dumped in the hole. Lots of ruts in the yard after that. I was actually kind of thinking he might break my concrete pad coming across it, but fortunately that didn't happen, and the ruts are something I had filled with dirt, and then it wasn't too long after that that more ruts were put in the yard by the crane, so got more yard repair work to do here also coming up yet. So one of the things that I worked on over the winter was the construction of a power divider. This is a design from Lance, W7GJ, based on some aluminum square stock. And I put in 7/16 DINs, which is a over-engineering type of a piece of work. I think ends would have been just fine, but yeah, I like the DINs, and I thought I would try them, even though that it's a little bit of overkill. And you can see basically it's Teflon spacers and a brass center conductor, and over on the right hand side you can see that the center pin to the DIN is soldered into the center of the brass tube, which is the center conductor, and then the ends are soldered as well. And this particular picture was taken down at KG99's house, where my brother N9DL went over there to do the final assembly with Dave. The machine shop in Milwaukee did a lot of this custom machining work. And he'd already done a power divider for Dave, so he was pretty familiar with what needed to be done. So I basically just had to get the raw material down there, and he was off and running and turned it around in no time. So that was a pretty cut and dry piece of work. So in November of 2019, the first pieces of hardware started to show up from K7NV. What you kind of see here is on the table is a medium prop pitch from Kurt with K7NV mass clamp on the top of it, and a green heron RT21 controller that's specially engineered for running these K7NV prop pitches. Works really well. A lot of torque. The other things that you kind of see scattered around on the floor, kind of going from the left to right, is the thrust bearing for the top of the tower, a cover for the thrust bearing, and then this drive sprocket that goes around the cross room. This is this particular sprocket came from a shop in Milwaukee that does sprockets. Didn't look like this originally. We had bought 2 of them and then shipped them out to Kurt, and he sent them to laser cutters and had them cut so that you could put a section of Rowan 55 tower in it and cut the holes in it so that the clamps would U-bolts would be able to engage with the cross boom. And the next thing next to the sprocket is the rotor shelf. There's no rotor shelf from Rowan that you can get for Rowan 65, especially for a prop pitch motor. So Kurt did that as well for me. And then the next thing, the bigger plate, is actually the top plate for the Rowan 65 with the hole where the mass comes through, and that thrust bearing mounts to the top of it in those 4 holes there. And then the mass clamp, the gusseted mass clamp that you see there sitting in front of that plate, it sits on top of the 3-inch chrome moly mass that sits out of the top of the tower that the elevation floor actually mates with. Also, kind of around that same time, the antennas from Justin started to show up. He ships them in these nice long tubes. One tube for each antenna. They actually didn't take that long to ship from England. I think it was just a couple of days. FedEx, they really came over remarkably fast. I mean, I think, you know, what I had ordered them probably 4 or 5 months before this, but the actual shipping time was extremely rapid. This is before COVID, so planes were still flying across the Atlantic anyway, on a pretty regular basis. Over the winter, I also worked on the phasing lines. These are made from LDF 4-50 heliacs with the DIN connector on the 7/16 DIN on one end and an N on the other. And these were all cut to about 0.1% electrical length of one another, as determined by using one of these Rig Expert AA230 zooms. And I spent a lot of time getting them that accurate. Probably didn't need to be that accurate, but I had never done it before, so I was kind of a stickler. Terry came over and helped me with these putting these DINs and ends on. I've never really worked with any of these VHF connectors. I was PL259 guy, so putting these compression fittings on was like, huh? Where do I put the solder? But they work pretty well. And if you have the right tools to cut the heliacs and kind of end mill out the foam, these are foam filled. This is foam filled heliacs, so you kind of have to kind of play around with getting that foam out of the end of it and flaring the end of the copper shield. But once you kind of get the hang of it, it went pretty smooth. I tested each one of them using one of these nice Palomar dummy loads to 1.5 kW just to make sure all the connections were solid. And it seems that our work putting these connectors on was spot on. We didn't have any problems with that. Whoop, went wrong way. So then the spring comes of this year, and it was time to get those tubes out of the garage that my wife kept stumbling over and asking me when I was gonna kind of get them out of our garage. And of course she thought that, you know, they would be out of sight, out of mind. But of course I started building antennas on the landing in front of where the cars are parked, and so they were there for quite a while. Two of them you can kind of see up on the hill in the background, and then two of them down here. I kind of built them down near the house and then moved them up near the tower as they were ready. As I kind of worked through the construction of these things and kind of looked at what you know, how they were constructed, I decided to add a little bit of an additional reinforcement inside these square booms. These are actually the HD version of the 12.49 meter LFA 8. And so this is actually a tapered boom design. But even with that, I thought, you know, there was a little bit of flexibility in these booms, more than I was comfortable with anyway. And I decided that I would reinforce them by pushing a 1/2-inch aluminum pipe all the way through. So there are two 20-foot aluminum pipes, one from one end, one from the other, and that kind of gives it a little bit of extra rigidity. Of course, the boom to mast clamps that Justin had provided. Also kind of were designed such that the mast, the same mast that the antenna mounted on, would also support the trusses. And so there's really kind of two problems here. The mast that I was going to be using would be a 3-inch diameter mast. His were only 2, you know, were designed for a 2-inch mast. And I didn't like the idea of having to extend these masts 3 feet up and 3 feet down and mess around with having to level these Yagis in place when they were in the air. I rather preferred the idea of having a truss tube that would stick up and mount to the boom to mast plate and then attach the trusses to that so that I could level the boom on the ground. Kind of a fan of doing as much as I can on the ground rather than having to mess around with things in the air, which is always a little bit more difficult. So these boom to mast plates were kind of custom machined from that same place in Milwaukee that I had going to, and like that did the power divider work. The clamps that you see there are the heavy duty 3-inch mast clamps from DX Engineering. There's 2 of them on each Yagi. I also decided to mount this boom to mast basically in the middle of the boom, so it's geometrically at the geometric center. And then, of course, now the thing isn't balanced, so I kind of just empirically worked through this by adding weight to the ends of them so that it would bring the balance point to where the mast came through. And that ended up being 2 4-foot steel welding rods that I put into the director end. Kind of sprayed them down with cold galvanizing and coated them to try to protect it from corrosion and, you know, having the dissimilar metals play against each other. It seems to be working okay, and they were fairly well balanced. I mean, this isn't a precision job, but it's pretty close, within an inch or 2. And then also Justin used these Kevlar, this Kevlar rope to, not Kevlar, it's a cord that he supplied to use as a trussing, and I switched that to use Filostrand trussing because I really didn't want to have to replace it after it's stretched because of an ice load or something. And Filostrand doesn't stretch. It's just, I think, a better choice of material for trussing lines. I only did single trussing. There is lots of schools of thought. I know other people have done V trusses and stuff like that for larger arrays, but these antennas aren't that big compared to things like K7 or KJ9I Dave has. So then about in April, it was time to start putting things together up at the tower. So we brought the rotor and the mast and all the plates, and my brother came up and we put all that together and put it on a sawhorse and got all that ready. I split a piece of 20-foot chrome moly mast with Dave KJ9I, and so you're looking at about, I think I have a 9-foot 3-inch chrome moly mast there with that gusseted mast clamp that is on the top, and there you can see the water shield that's on top of the thrust bearing there. The other thing that you can see in this picture, if you look really close, is I also built a piece in a weather protection shield around the azimuth prop pitch rotator out of very large sewer pipe, PVC sewer pipe, with a big cap on the end of it, and it's got some clamps to hold it to that rotor shelf, just to kind of keep the elements off from it. Those rotors are pretty pricey and they look really nice. So I'm kind of went out of my way to try to preserve that look, and keep them out of the Minnesota weather as long as I could. At least for this, with this azimuth rotor, I really couldn't do much with the elevation rotor, but with this one I could. And then after I got all that built up, I wanted the sawhorses to be able to build the elevation rotor and the cross boom. So got a bunch of guys over and manhandled that top section of Rowan 65, which after you get the rotor and the mast and all the plates, it's, you know, it's probably about 350 pounds. So it was a little bit heavy, but we got it hoisted up there beside the section sticking out of the concrete, and I basically tied it up there with some straps to hold it up there good and tight and secure it until we could put it up on top, and it stayed like in that position for about 4 months, I think, until the crane came anyway. So then it gets us to about May, and we have been having pretty much weekly conference calls with K7NV on the design of the elevation rotor. And kind of what you're looking at here are the mechanical drawings for the elevation rotor system. Kurt is the primary designer here, although K7PN, Paul Nyland, who does some rotating tower system bearings for his job, his business is in Oregon there, agreed that he would build or design and fabricate the plates that the Rowan 55 would go through, and the bearings that would allow the Rowan 55 to spin. So K7PN did those plates and the bearings associated with the turning of the cross boom, and Kurt did the rotor floor and everything else, and all the prop pitches and the plates to mount the prop pitch. And you can see from the top down view, there's some handles that are on there to kind of allow you to grab it when you're installing it, and then also to kind of grab it to climb up and do maintenance on it. The holes that you kind of see there are for access underneath when you're tightening the bolts to the plates that hold the prop pitch and the pillow block, which you kind of see in that right drawing. There's a couple of plates that are cantilevered off to the side and are sticking down, and there's a small prop pitch motor that mounts on that right plate, and then another a shaft, 2-inch diameter shaft, steel shaft with a mass clamp, and then a sprocket. This is all a chain drive, so there's the big sprocket that goes around the tower, and then also a smaller sprocket that is on that shaft, and then that shaft terminates into a pillow block bearing that's on another cantilevered plate there, and then there are jack screws that are on the bottom of this plate that allow you to adjust the position of these plates to tension the chain when you're doing the final assembly. The other thing that's in the four corners of the rotor floor are holes for lifting rings. Essentially, I mean, you kind of have to have some way to lift this with a crane or a telehandler or something when, you know, once you get it assembled. And so these lifting rings are where the crane attached his straps to lift the assembly into the air. Once the designs were done, then we went into the fabrication stage of the project, and this is a picture of all the plates, about 30 of them for both rotors that came back from the laser cutter. You can kind of see in the box are the parts that would be welded together to form the cantilevered plates where the pillow block bearing and the small prop pitch motor would attach to. The plates that are further back on the pallet are the things that are the plates for the rotor floor, and actually the plates with the slots in them are the actual cantilevered plates, horizontal piece of them that slide in and out with you're adjusting the jack screw. So then once you got these back from the laser cutters, you basically acid washed them and sent them back out for zinc plating and epoxy plating. So then it was time to figure out how we're going to get all this hardware back to Minnesota and Wisconsin. And there was quite a bit of discussion back and forth between Dave and I as to whether or not we wanted to have these shipped or if we wanted to pursue some other means to get them. Dave actually had some problems with FedEx and had lost some critical parts that had to be custom fabricated, and had difficulties in that space and didn't have a very good feeling about shipping these things. That and a number of other factors kind of drove us to this conclusion that we were going to make a cross-country trip to go pick them up. So my brother, N0TB, who's graciously allowed us to use his brand new 2020 GMC Denali to drive cross-country, and it kind of was a huge factor because it was an extremely comfortable trip in that vehicle, and kind of made the whole thing possible. 4 guys and in a smaller vehicle would have been torture, but it drove really nice, and we decided that we would, because of the weight, they're about I can't remember what the exact numbers were on them, but I'm thinking that there was about 400 or 500 pounds per rotor, per elevation rotor system, and so we decided that we were going to pick up a U-Haul in Minden, and then put one of the elevation systems in the U-Haul and the other in the back of the pickup truck, and that this truck did a really nice job with pulling that U-Haul. It had some really nice features for automatically braking going downhill using downshifting that really made that, kind of took the workload off from that drive from Minden to Byron. We stopped in Spearfish to say hi to W0VB. In fact, W0VB took this picture. The other guy that came out with us on this drive was Ralph Pellegrini, a 9BDR. We all were extra class hams, and so we put a radio in the truck and a little mag mount antenna and listened to 2 meters the entire way. didn't hear very much, oddly enough. I think when we went through Salt Lake, we heard a few guys talking, but it was pretty quiet on 2 meters in that trip. About 39, it turned out to be about 3,900 miles round trip. On the way out, we actually broke it up a little bit with a stop in, we went to Devil's Tower, Wyoming, checked that out, and then drove to Casper, Wyoming, stayed overnight there, and then made the next day we drove from Casper to Reno, stayed overnight there, and then got up in the morning on Monday and drove the rest of the way to Minden. Here's a picture of Dave, KJ and I, kind of white knuckle driving across the salt flats just west of Salt Lake City through 60 mile an hour winds with semis that were just about ready to tip over on us. And so Ralph is trying to kind of coach him a little bit and talk him, you know, get his nerves calm for this particular section of the drive. This was kind of the most excitement that we had on that drive was this 60 mile stretch from Salt Lake City into the Nevada border. Kind of packed all the body joints of Dean's truck with salt, which didn't make him too happy, but I'm hoping that a good cleaning got all that out of there. So Monday morning, about 9 a.m., we arrived in Minden, Nevada at Kurt's K7NV's QTH. You can see in the left picture is Dean's truck with the U-Haul trailer, and the heavy parts, the real heavy parts, the rotor floors were still in the back of Kurt's pickup truck, and so we're just preparing to get those out of the back of it. In the right picture, you can see Dave kind of looking at it, and I'm actually taking video. One of the things that I did there was to kind of document this whole process, this assembly process. We only spent about 2.5 or 3 hours at Kurt's house. So it was really quite a whirlwind type of a tour here. So we were, really focused on getting the information, that we needed and put it in a form where it would be easily accessible to us. So we put together this series of videos. We took the videos on iPhones of Kurt describing how all this stuff went together, so that we could refer to it in the next couple of days after we got back to assemble it. Kind of in front of the house on the sawhorse, you can actually see some of the plates where the small prop pitch motor is mounted to, the cantilever plates that hang off the side. The actual rings and vertical plates are also near, right to the left of that, but they're kind of cut off in the picture. Here's a close-up shot of the Elevation Rotor floor. These are 1/2-inch thick steel plates, about 150 pounds each. They have gussets mounted on the sides, and then underneath there's a set of gussets that go from one side to the other that give it additional strength. It's really pretty impressive piece of steel. And it's actually coated with an electrostatically deposited epoxy that makes it pretty durable. At least we think so, and it looks really sharp. They did a really nice job with this. All the other parts were primarily zinc plated, and we would have zinc plated the rotor floor, but the tubs that they do this in are that has this molten zinc weren't big enough to actually submerge these these plates into them. So kind of forced us to do this electrostatic deposited process rather than zinc plating. Kind of a shot of the truck and the trailer just prior to us leaving Minden. Dave's rotor and all his parts were in the pickup. Mine were in the U-Haul, and you can see in the back of the U-Haul there, leaning up against it, are the rings that go around the cross boom and ride on the inside of the bearings that are on those vertical plates that came from K7PN. And like I said, we didn't spend a lot of time there. About 11:45, we were done and had all the videos made and exchanged pleasantries and hit the road back to Byron. Took a final picture of myself, Dave, and Kurt, and proceeded to drive 32 hours straight back to Byron. That was quite an experience. One thing that was really nice is that Ralph N9BDR was just itching to drive the overnight part of that trip. So that really helped. Although I don't think anybody really slept. Couple of pictures of the assembly of the elevation rotor. These pictures were taken of my system before they left Byron to go back to Dave's house. They graciously agreed to help me put this thing together in the backyard. So we put it all together on the pallet and sawhorses that you saw previously in other pictures. And here you can see that on the left picture there is a pretty good view of those vertical plates from K7PN with the big hole in the middle for where the cross boom goes. The picture on the upper right shows that we have now the center section of Roan 55 kind of positioned in between, like through the holes, and the main and the drive sprocket kind of loosely positioned there. Really, the alignment of this thing is kind of tricky, and so you just kind of put it together loose, and then once you get all the parts in their approximate positions, then you can kind of fine tune it. Spent quite a bit of time in that lower right hand picture shows the whole finished assembly. Aligning the two sprockets with one another so that they run true, and the tower is spaced, aligned properly, centered in that hole. The bearings are kind of equally spaced so that there's, as the tower rotates, you don't have any gaps or anything like that. Took a little bit of time, but it's a fairly straightforward iterative process. But it does take a couple hours of fussing with to kind of get everything all square and true. Everything's got to be perpendicular. You don't want that chain hopping off the sprocket as you're rotating it. Oddly enough, we actually did have that happen at KJ9I's house. Kind of a long story, and to make it short, it was kind of one of these situations where the installers were putting up his antennas and decided that they wanted to rotate the whole thing. They put the two bottom antennas on Dave's array, which are big. He has much bigger antennas than I do. He's got 4 10s up, and each one of those antennas weighs 150 pounds. And so the bottom two are on, and the tower installers said, well, let's just rotate the whole thing over 180 degrees, and we'll just tip it upside down and put the bottom ones on. But the thing that they didn't really consider is the tremendous amount of torque that drives back into that prop pitch motor. And when they did that, they got it up to about, they started rotating the elevation rotor to invert it, and they got it up to about 45 degrees, and that chain slipped off that sprocket, or jumped the sprocket, scared the living crap out of everybody, and then it back drove the prop pitch motor all the way back down to, you know, so that the antennas went right back down to the bottom again, and then it was like, nah, maybe we better not do that. But I mean, that was kind of a scary time, because we didn't know whether or not we sheared the pins in the key shaft. There's a keyway that sits in that smaller sprocket that kind of holds it on the shaft. We didn't know if we sheared that or if we sheared something else. Yeah, so that, but it turns out everything was okay, and it just jumped that sprocket. I think you can pretty much, in the upper right hand picture, you can see the shaft that goes from the, you know, from that pillow block in, you know, through the mast clamp, and the spline that's the output shaft of the small prop pitch. It all fits together. It all fit together just perfectly. No problems at all putting it together. About that same time, I trenched put all the trenches in for all the cables. My brother N9DL came up and sawed a hole into the foundation of the house, and we got all the cables all routed up into the shack. And then we put the rest of the cross boom together. Here you can kind of see the vertical components of the H frame. They consist of two 3.5 inch, 1/4 inch thick aluminum tubes, 20 feet long. And then on each end of it, there's a 10-foot section of 10-foot piece of 3-inch aluminum pipe, 1/4 inch wall that telescopes into that with about a 5-foot overlap. And then there's, you know, bolts that go through and secure that. And it's actually shimmed a little bit too with some shim stock, you know, to make sure that it's a good tight fit. You can also see the trussing for the vertical components there. You can see the trussing for the cross boom. So this is basically ready to lift into the air, is the way it sits there. These are the plates. These are, again, custom made, custom machine plates that came from that same machine shop in the Milwaukee area that fit on the end of the cross boom. And looking at the right picture, you can see that there's about 8 of these 3.5 inch clamps that come from M² that hold that those vertical members of the H frame. And then there's a plate that sits over the top of those, and that holds the 2-inch tube for the truss supports for those vertical H frame components. So in all, there were 22 custom aluminum plates that were done from this guy in Milwaukee, that machine shop. You know, the end plates, a lot of plates for the truss lines connect, boom to mast plates, just a lot of, you know, little custom made pieces that you gotta have to put the whole thing together. So come August 1st, it was time to bring in a crane and have them lift all these pieces into the air. It took about 6 lifts and 4 hours of crane time to do it. We lucked out, and we had calm winds and clear skies and great weather. First thing to kind of go up, obviously, was the top section of tower, and then we lifted the cross boom and the H frame. You can see that in that middle picture that the crane operator brought their straps, and they're basically tied into those lifting rings that are in the corners of the elevation rotor floor, and that really made for a slick lift. I mean, that was a very smooth operation to take that thing and lift it up into position. I don't know what else I can say about that. There's videos of all this stuff out on my photography website. If you're so inclined, you can kind of look at the videos of how this actually played out to see how smooth that went. That's on the tower is Ralph Pellegrini and N0TB and myself. Ralph is an old tower guy who used to work for AT&T. He still works for AT&T, but he used to be one of their tower climbers, and it was nothing for him to climb a small tower like this. He's used to climbing 1,000-footers, and so he's really really good at knowing how to talk to the crane operator and direct them with hand signals, and kind of keep everybody in line. And he was a great resource and a tremendous help to have on site. We also had a man lift there that we used to kind of go up and attach the Aggies onto the ends of the vertical parts of the H frame. You can kind of see we took it up in a horizontal configuration, but we had the rotor controllers all ready to go. And as soon as we got that up there, one of the first things we did is we rotated the elevation rotor so that the pipes, the vertical components of that H frame then were vertical, and we could attach the Aggies basically in that position without having to do any more elevation movements with it. We did a lot of azimuth movements. We basically rotated the azimuth, using the azimuth rotator to kind of move the ends to where the man lift was, just because the backyard has a lot of sloped ground, and that was kind of a tricky thing to kind of navigate to keep that man lift happy. And that whole process was very smooth. The only problem that we had was we broke one bolt when we were tightening the boom to mast clamps, and we think that was probably because it probably had a stress fracture in the bolt, and fortunately we had a spare, and we were able to replace that with no problem. And get the crane operator out of there in 4 hours, because if you pay one amount of money for 4 hours and then it jumps to 8. So it was really important to keep the crane guy on schedule and on task. So organization was kind of key in that whole day. I mean, you really wanted to have the workflow all figured out and everything ready to go, just so that the guy's not sitting there waiting. We talked a little bit about the sloping ground and the constraints that made to the man lift. You can see kind of off on the right-hand side. The picture there is a picture of me doing some of the taping work. We had the crane out of there by about 11:15 or 11:30. Then we grabbed a quick lunch, and I think we worked until 7 o'clock, doing taping and doing alignment. And it turns out that aligning these antennas so that they're all parallel and perpendicular to the cross boom is a little bit of work, and mostly I think the challenge there was primarily because these big DX engineering clamps really hold. Even though you loosen the bolts, it's still hard to turn those antennas and make an accurate adjustment of those Yagis with, in any precision manner. So it was kind of an iterative process to get all these antennas to be aimed properly. So like at the base of the tower, I have a utility box, which you can kind of see on the left there, which holds the SSB Electronics LNA. It has a couple of terminal barrier strips there mounted, which are basically a handoff from the cables that come from underground, the rotor cables for the prop pitch motors, which are 6'3". And then as they go up the tower, they're 8'3", just for a little bit, to give you a little bit extra flexibility for a rotor loop. And then the top terminal strip is for the pulse counter coming from both prop pitch motors. I also have a convenience AC outlet that's there, and you can kind of see that there's the two Green Heron RT21 boxes are sitting on top of there, and they're basically plugged in so that we could run both the elevation and the azimuth rotors from right there at the tower site, rather than having to run back and forth to the house a couple hundred feet down the hill. That was a pretty convenient thing to have. The other thing you see in the box at the base of the tower is some lightning arrestors. On the other end of the cables is in the shack, I have another utility box that basically serves as a termination point from the cables as they come out of the wall. And again, terminal strips that allowed the handoff to smaller gauge wires. And you can see the two Heliax the LDF 4-50 lines coming out, which have right angle connectors coming out of the wall, poking out of the wall, hole in the wall there as well. Yeah, and this is kind of what the whole thing looks like as it's finished. I tipped it up here to about 30 or 40 degrees and flew a drone up to take this picture here a couple of weeks ago with the fall leaf color change. And you can see off on the right-hand side there, just to the right of the house, there's the 90 or 80-foot Roan tower for HF with the Mosley Pro 96 and the M² 6M5 XHP on top of that. Here you can see, in this picture, you can see the cable hangers that were provided so graciously by Ralph to run these cables up the tower. On the left side is the LMR 600 UF. I decided to use that just so that it was a little bit more flexible when it comes to the rotor loop as you go up to the elevation rotor on the top up there. The two cables over on the right-hand side are the power for the prop pitch motors and the pulse cables for the prop pitch motors. One for azimuth, one for elevation. So in general, in terms of what's in the ground there, running from the house out to the tower, I have about 171-foot run there, which holds, which has a sort of 4-inch diameter irrigation drainage tube that contains 2 runs of LDF 4-50, one kind of as a backup in case something happens to the first one. The 2 runs of 6 3-gauge wire for the prop pitch motors. A run of a flooded telephone cable that I use to run the pulse signals over from each of the prop pitch motors. A couple of runs of Cat 6E just for future use if I ever want to have internet out there for some reason. A run of 110 volt line just for the convenience outlet out there that I can take my rotor controllers out, or soldering irons, or heat guns, or whatever that I need to plug them in out at the tower. A run of 75 ohm CATV and power for future use in case I ever want to put a camera out there. I know a lot of EMEers like to have cameras out on their antennas just to verify that they're aimed at the moon. I haven't done that yet. I've been pretty happy with the ability of these prop pitch motors to retain their counts, and they seem to be holding their calibration very well. And then a run of RG8 for the preamplifier power from the shack out to the SSB Electronics preamp. I also have up the tower then is 39 feet of a 39-foot run of LMR 600 UF, and 2 runs of 10-3 for the rotor motors, which are pretty flexible. It makes for a good rotor loop. For kind of a general overview of the station block diagram, you can see I used Flex 6500 and a Flex PGXL. In between that, I have the sequencer that I use to protect the preamp out at the base of the tower. And then also an Antenna Genius that I use to select either the 6 and 5 XHP or the HF antennas or the EME antenna. And also you can kind of see that there's a run of LMR 600 UF from the preamp up to the power divider, and then the green heron controllers for both azimuth and elevation. Kind of looking at the sequencer a little bit, just to kind of give you a little bit of an idea what that is. This is a design that was from VE2ZAZ and QST years back, based on a little microcontroller. What you see on the card in the left picture is the kind of the long chip is the microcontroller, and then all the other things along the bottom near those screw terminals are optical isolators. So all the outputs are optically isolated, and then you see a little voltage regulator and an RS-232 to TTL conversion chip, and some LEDs for showing you when the outputs are actually either on or off. The right picture kind of shows you the inside of the box. 2 power supplies, one for the logic, 5-volt logic, and then there's a variable voltage 16-volt power supply for supplying preamp power that comes out through that little piece of coax that you see kind of wound in to the right connector on the back side there. In terms of software, pretty straightforward. I mean, this is kind of not unusual for people to do EME. I like to use WSJTX. Others seem to like WSJT10. I've done comparisons between the 2 of them. And I found that, at least in my setup, that the WSJTX outperforms WSJT10 almost exclusively. I've never seen a case where WSJT10 decodes something that WSJTX does not. Which, I mean, in a weak, under really weak signals, WSJTX seems to decode better than WSJT10. Although I do use WSJT10 for its echo test mode. you know, to kind of grade the quality of the returns that I'm getting off the moon. Like I like to use it, and I'm sure others like to use this Moonskid program that shows you the degradation and sky temperature and declination, and lets you kind of figure out when you need to, you know, kind of prioritize certain times, or, you know, like when the degradation is low over when the degradation is high, kind of improve your chances of making some of these schedules work. And then obviously the main window on the bottom right picture is kind of how you use it to select the two stations, and it shows you, you know, what the windows of opportunity are there, and what the elevations are like on each station, and the times, and so on and so forth. So, I mean, it's actually a really handy piece of software. I use this a lot when setting up schedules. Since I have a flex system, I use the Smart SDR, obviously, to as my control window, the window that I'm running the radio with. I use the PST rotator for controlling the azimuth and elevation of the EME array. That works really well. Logging, for me, I just use log4OM. There's really nothing special about that. That's just personal choice. I just wanted something that that would, you know, basically talk to Logbook of the World and WSGTX. And really, it's nothing more than that. Although for contest, others like to use N1MM or whatever. I also use Slice Master with my station in the Flex setup to launch WSGTX or JTDX or CW Skimmer. I mean, I'm still an HF guy, and if you get a really big pileup, sometimes it's nice to have CW Skimmer there watching the whole pileup, so you can find out who the DX is talking to. That's always you know, kind of a nice little tool to have in your back pocket. And of course, the Antenna Genius for the antenna switch that basically follows me around on whatever band I happen to be operating on. So to date, I've worked 10 new ones off the moon since August 1st, and you can kind of see here's the list. The last one I just worked was VAL in Kazakhstan, UN3G, which was a big challenge for me. I know others have not had such a hard time with it, but I've had to work at that one for a little while. Val has a noise problem, and so it's a little bit of work to get him to be able to hear. I was also fortunate to kind of meet up with the guy operating on the Falklands here a couple of weeks ago, or maybe a month ago now. And I think that screenshot is him, VP8 DPD. That was a new one for me. That was kind of cool. That one was a little bit of a challenge because there was actually a thunderstorm, a line of thunderstorms approaching from our west, and it was within 10 miles. I was ready to disconnect and pull the switch and tie the array down. I mean, I really didn't want to be out there tying the array down with, you know, lightning within a mile. But this guy was, it's like, oh, we're almost there. You know, it's like, I got, you're, and, we just a few more minutes. And it's like, oh my God, it was very, very nerve wracking. It was, but we made it. And he's like, okay, we're good. I was like, I think I shut down the amp and parked the array and ran out and tied it down in record time. It was close. I tell you, it was kind of a little bit of a stressful time for that particular QSO. Here's a quick picture of the EasyNeck pattern models from G0KSC for the array. You can see that it's about 17.8 dB gain reference to a dipole, with minus 19.75 dB G over T, which is pretty respectable for in the 8-element Yagi class. The ERP is about 75,000 watts with that 17.8 dB gain and 1 dB of cable loss out of from my PGXL driving with 1500 watts. And the 1 dB, the 1 dB beam width is about plus or minus 3.5 or 4 degrees in azimuth. A lot of people, I mean, when they show these plots, they show the the 3 dB plots, but boy, I tell you, if you're off 3 dB off the moon, I mean, you're really off the moon. So I tend to like that 1 dB beam width figure a little bit better to give you an idea of what kind of pointing accuracy you kind of have to have in order to hold your signal on the moon. And like I mentioned, I mean, this was a huge, huge job, a lot of time, a lot of work, and there's a lot of people that helped. And I mean, Dave, KJ9I was huge, and all of his technical guidance and being my EME elder, and doing a lot of the groundwork for this elevation rotor assembly. I mean, this all kind of started back in Dayton, when Dave and Kurt met and started out talking about using a Roan 25 as a cross boom, and it wasn't too long after, I mean, just a matter of minutes after him and Kurt were talking about it, and I got a call from Dave saying, "Oh, we've changed from a Roan 25 to Roan 45." And then an hour later, get another phone call and say, "Oh, we've changed from Roan 45 to Roan 55 because we want the higher, we want the heavier duty wells." So it was a pretty fluid design session that was going on in Dayton between Dave and Kurt, but the Roan 55 thing stuck. And Dean, my brother, and 9DL, with the use of his truck and running the man lift and coming up to help me drill the block cores was a huge help. And like I mentioned earlier, Ralph was a great guy on the tower. He provided those cable hangers, and of course, that, like I mentioned, he did the overnight driving run for us, which that was tough. Terry was big help with the phasing lines and helping me build the Yagis and putting those tubes inside the booms, and he's been a great general VHF Elmer for me. And you can read the other guys too, Tom and Mike and Pat and Fat and Fred and my friend Jim Krieger, who's been huge help to me coming out and getting their hands dirty on all these huge, tasks that needed to be done. Here's some reference info if you're so inclined to go out and look at some additional pictures. You can see these links are to my photography website out on SmugMug, and links to the VE2ZAZ article on the sequencer, the charts, the Excel charts from Lionel, or link to those. Huge help. Boy, those are like the Bible when it comes to selecting antennas. Thanks a lot, Lionel. Those are really a tremendous piece of work. There's a link to K7NV and some technical literature he's got out there on some wind load topics, and then finally a link to the Roan catalog for some of the wind load specs on the various towers that I looked at. So this is the last chart. Thanks, everybody. And here's a couple of gratuitous pictures of the moon. I think almost every EME operator that has an array or does EME work. They love to take these pictures of their antennas aiming at the moon. So I kind of felt obligated that I had to do that. So with that, I will turn it back to you, Paul, and you can open it up if there's any questions.
Yeah, okay, great. Thank you very much, Tim. And I still think it's a beautiful picture of that antenna there with the moon behind it. I'd love to, I wish I had a system like that myself. And I guess I kind of do moon bounce vicariously through you. Anyway.
Well, I did it vicariously through a lot of other people prior to me putting this up. So
Right, well, when I get, maybe I can do it remote from here to your place.
there you go.
That'd be
Oh,
fun.
with these flex radios, that's certainly doable.
When you're not busy, you know, or when you're busy doing something else, I'll just take over your array.
Yeah.
Anyway, I'll let the other guys dig in here and ask a couple questions, and then we got to wrap it up here because I'm recording this and I'm running out of space. So, okay, I'll put it up. Anybody else?
I've got a quick question for you, and I promise not to tell your XYL, but how much did you spend on this?
It's not a cheap endeavor, Lloyd.
I'm guessing 50,000 plus.
No, it's not that much. No, I mean these rotors. The most expensive piece of these things are those prop pitch motors, and you know these prop pitch motors run like $6,000 or $7,000 for the medium one, and $3,000 for the small one, and the it's like by the time you add all that up, I mean it's probably half of what you're guessing there, but I mean it is not cheap. I mean Kurt's work is really extraordinarily well done, but then again he charges for it, but it's worth it. I think in the end it's very high quality and over engineered. I really didn't want to wake up in the morning to a pile of aluminum in the backyard after a winter storm or a thunderstorm, so that's why I kind of went a little bit over engineered. Plus the thing you have to kind of also think about here is that this was actually designed for much bigger arrays than I have. Like I've mentioned in the talk, KJ9I has, 4 10-element Yagis up on his system, and those have 60-foot booms. And so really it was designed for something of that magnitude. So for me to go to 4/8 was actually a pretty conservative choice. I think it'll probably do well.
Well, then since you have some extra capacity available, have you thought about adding antennas for, say, 2 meters?
I have, and actually, that's a really good question, Lloyd. And actually, that's the thing that's been floating around in the back of my head as a use for that extra LDF 4-50 they have running out there, is to mount a 2 meter, long boom 2 meter Yagi out there and start doing 2 meter EME. That's something that I'm not going to do this year, but you never know. I might decide to throw something out there on it, in a year or two after I get bored on 6 meters. But I don't want to really, I'll have to kind of talk to guys and figure out, what kind of effect that has on the 6 meter performance. I really don't want to, have, any detrimental effects, on the array, on the 6 meter array, but it would be cool to try 2 meter EME also. But I'd have to get a different radio.
All right, thank you.
You're welcome.
A quick question from my side. Did you have to use any one-to-one transformer for each antenna, or just direct coax?
There are ferrite balance on each of the antennas. Actually, if you kind of look at the picture of the Yagis as they were sitting in the driveway, you can kind of see that there's a little bit of a hump in the heliax when it comes, down the boom, and then it kind of ramps, kind of comes up and then comes down at about a 70-degree angle. That last piece where it's coming down from that hump is actually the ferrite balance that Justin G0KSC provided. So that's what I do with those. Now, on the other hand, I could have done, wound, balance out of coax, but, I was getting tired of of all these little details, and I just thought, well, it'd just be easier to go with the ferrite balance from Justin. So that's what I did.
Thank you.
Any other questions?
Yeah, Tim, we worked 6-meter meteor scatter.
Oh, hi, Chris.
Times. Hi. It's kind of an embarrassing question to ask, but what would be the lowest power station that you might consider giving me a try? In other words, I got a 4-element LFA, 100 watts. Any point in even thinking about it, or is this just silly?
The smallest array that I've worked on EME, well, I guess worked, I guess is the operative word there. I mean, Val is running a 6-element Yagi, but he's got power, a kilowatt. There's been some VKs that I've worked that, have 7-element Yagis with, I think, 500 watts. I've decoded BV3UF, who I think has maybe a 6. I don't know, Lance might know exactly what he's got, but he's running QRP with, probably a couple hundred watts, maybe I'm not sure exactly what he's running, but I know he said he's running low power. But that's tough.
Yeah,
I think a 4-element is kind of on the low side with,
yeah. No, I gotta get me an amp. I was gonna steal Paul's when he wasn't looking, but I don't think that's gonna work out. I gotta buy me one.
Yeah, I think if you had a 6-element Yagi and a kilowatt, you'd probably do fairly well.
Okay.
Like with ground gain, without elevation.
I've got elevation control. I've actually got them strapped to the top of the.
That's great. That's great.
Other thing, and a really quiet area here, but I need some power. I know that. I've actually
power
talked to Paul about that already.
You might pull off some contacts with 500 watts. But.
Yeah.
I think it really helps to have that kilowatt if you can get it.
Oh, okay. Thanks, Tim. I'll talk to my wife.
Good luck, Chris.
Anything else, guys?
Yeah, right. I think I've got myself unmuted now. I had a question about polarization. I've never compared 2 and 6 meters, but roughly how much polarization do you know you might get there? Because
like Faraday rotation effects.
Yeah.
Yeah. Well, that's a real problem. It kind of manifests itself as kind of QSB. There's just days where it's my day in the barrel, and Faraday rotation makes an EME QSO almost impossible.
Oh yeah, I've experienced that on 2 meters a lot.
Oh yeah, it's even worse on 6.
That was really what my question was. How much?
Oh yeah, it's much worse on 6.
Oh boy.
But it's just I'm sure Lance and the other guys that are on EME can do a much better job answering this question than I can. But I can tell you that it can be very frustrating. Some of these QSOs can take an hour or more, where you're just sending OOO or whatever and waiting.
Oh yeah, been there, done that on 2 meters.
Yeah, and so I don't know. If it's in northern, I'm not really sure if there's any correlation with northern latitude versus southern latitude or whatever. But
I'll have to dig into it. I'm curious now that I asked the question.
Yeah, I know that I've had guys, like I know when I was trying to work UN3G Val and Val wasn't hearing me, and then I said, all right, I spend last hour and a half and it's just not working, and then have people that have running smaller antennas basically come in and work them in 3 sequences and say thanks. that was kind of easy. So it's just variable. It varies from location to location, station to station, and
Yeah, I just wondered how 6 and 2 compared. But,
Yeah.
I'll have to-
Here you go.
Well, typically 6 meters Faraday rotation is faster than 2 meters, but lately with the low K index, it's really, there are times when it really drags out. And as Lionel knows, if both stations are in the dark, it can just stall out on you. So
Yep.
6 meters is probably the worst band for EME because of all of the stuff that could go wrong, the noise, the scattering, absolutely any little perturbation in the ionosphere is going to screw you up on 6 meters, whereas the higher bands aren't so vulnerable.
Thank you.
Thanks, Lance. That was good.
Okay, I see a note from VK5PJ.
Oh, hi, Peter.
Are
I've
you-
worked him. Most of us EMEers have probably worked Peter. Got a good signal.
Are you able to unmute there, Peter? I didn't see any note from him. I don't know. He may be having some technical difficulties. Maybe his mic doesn't work. Anyway, guys, thank you very much. Tim, you've done a lot of work there putting this presentation together, and all the details and everything else behind it is just awesome. I love the antennas, and I think you've done a great job, and you're an inspiration to everybody here who even wants to think about EME. I've got a pair of 6-element beams on a kilowatt, but I don't have any ground gain downtown. Got too many buildings around me, so. I think it would be really a tough uphill battle to work you on the EME, but
Well, you never know. It's like, that VP8 that I talked about.
yeah,
The moon was actually at 20-degree elevation at his QTH, and he had an antenna with no elevation.
well,
So I mean, it might surprise you.
well, maybe one day when we can give it a try, Tim, and see if it,
I would say the hardest thing would probably be receiving,
Yeah.
and that's always kind of the tough tough nut to crack is noise.
and the moon always rises in the east. I do wish I could change that, but
But it sets in the west, so you're okay there.
yeah, I got mountains to the west of me.
Okay, all right.
That's the problem with living in Colorado. Anyways, thanks a lot. And just for those people on board here, the next presentation is going to be by a gentleman by the name of Chris McIntosh, who is the Deputy Director of NCAR, which is the atmospheric research guys. And they have a very optimistic forecast coming up on the sunspot cycle that's coming up for cycle 25. And for those guys who want to dream about F2 multi-hop on 6 meters, this might be the guy to talk to.
That'd be cool.
Anyway, I just saw another note from Peter. Says, Paul, do not discount the lobes at high elevation angles from your Yankees. Okay, I'll do that myself there, Peter. Thanks again, guys, and I'll see you guys.
Paul, do you have a date on that next presentation?
I sure do. It'll be on the fourth Wednesday of the month, which in this case is October the 28th. Same time, same station. And
Thanks very much.
yeah, I heard a little bit about his presentation once on one of these podcasts, and that just fascinated me. So I called him. He's up here in Boulder, by the way, not too far from where I live. And he agreed to make a presentation to our group, and I want him to tell us all about what's going on with the sunspot cycle and why is it going to be the mother of all sunspots. So we'll find out, guys. All right, so we'll see you guys later. And
And we'll see you on Tropo.
thank you.
Good night, everybody.
Good night.
Thanks, Tim.
Thank you, Tim. Thank you, Paul.
Welcome. Bye.
Good night, all.
Thank you, Tim, and thank you, Paul.